This is the video lecture for CHY 40.1 Principles of Chemistry Laboratory. For the laboratory safety rules, you have to familiarize the do's, the don'ts, and the rules in the laboratory. Also, the GHS symbols or the globally harmonized system hazard pictograms. For the activity 1, the formula writing and naming of inorganic compounds, you also have to memorize or familiarize the different common cations and their oxidation states, as well as the common anions and their oxidation states. You have to take note, especially for the cations, that there are elements that are the same elements and but different oxidation states. So for example, for the chromium, it has positive 2 oxidation states and also 3 plus oxidation state. So same with the cobalt, the iron, the lead, the tin, the antimony, and the arsenic. For the anions, um, though they have the same oxidation state, but they have different number of oxygen attached to them. So for example, for chlorine, the ClO minus is named as the hypochlorite, while the ClO2 minus is chlorite, the ClO3 minus is chlorate, while the ClO4 minus is perchlorate. So you have to take note also for that. So formula writing using the crisscross method, the steps is the cation is written first, followed by the anion. Then write the correct subscript for each atom, and then the subscript must be reduced to the simplest ratio. So note, if there is no subscript, it is understood to be 1. So example, barium sulfide. So the barium has positive 2 oxidation state and sulfur has negative 2 oxidation state. So using the crisscross method, the oxidation states will be the subscript um, of the other element. Um, so the last rule is that the subscript must be reduced to the simplest ratio. That is why the final formula should be written as this, like this. So next example is the plummic sulfate. So lead has a positive 4 oxidation state and the sulfate has negative 2 oxidation state. So using the crisscross method, the oxidation states will be the subscript of the other element. Okay, so the last rule is that the subscript must be reduced to the simplest ratio. That is why the final formula should be written like this. Okay, naming of compounds. So first is for the ionic compounds. So ionic compounds are compounds made up of metal and non-metal. So for the naming, the name of the first element is mentioned first. The name of the compound ends with IDE. And in case of metal ions that exist in more than one oxidation state, you have 2 methods on how to write or to name the ionic compound. So first is using the old naming. So it uses the OUS or the IC as the ending. So example, the FeCl2 and the FeCl3. So for FeCl2, you know that the iron here has a positive 2 oxidation state. So it is named as ferrous chloride. While in FeCl3, the iron has a positive 3 oxidation state. That is why it is named as ferric chloride. So as you can see, the less oxidation state should have the OUS suffix, while the higher oxidation state has the IC suffix. So the next method is the use of oxidation state. Okay, so same example, FeCl2 and FeCl3, but in the use for the second method, you use the oxidation state. So you name the element, for example, the iron plus iron, then its oxidation state, which is 2, and then the anion, the chloride. So same with FeCl3. Next is the covalent compound. So covalent compounds are compounds made up of 2 nonmetals and For its naming, the guideline is that the name of the first element is mentioned first, then the number of atoms of the element in the compound, especially the second element, is indicated by using appropriate prefixes. So the name of the compound ends with IDE. So the most common prefixes are listed here. So you have to familiarize this also. And for our example, so CO. So as you can see, for CO, you have one atom of carbon and one atom of oxygen. So its name is carbon monoxide. Then the CO2. So as you can see, for CO2, you have one atom for carbon and two atoms for oxygen. That is why it is named as carbon dioxide. So for the third example, CCl4, you have one atom for carbon and four atoms for chlorine. That is why it is named as carbon tetrachloride. So for P2O3, you have two atoms of phosphorus and three atoms of oxygen. That is why its name is diphosphorus trioxide. So you might ask why wala ka nabutang diri og monocarbon monoxide. That is because it is very understandable already. So you put a prefix, especially on the first element, if dili one iyahang subscript. So next is acid. So change the non-metal element with the suffix IC, then add the word acid. So for binary acid, these are compounds made up of hydrogen and a non-metal. So example, the HCl, HBr, HI, HF, and H2S. So the name of the compound is this, but its name as an acid is like this. So you put the hydro, then you put the suffix IC and the word acid. Second word as acid. So inana pagsulat sa compounds sa binary acid. But kung inani mong pagsulat, this is also correct and this is also correct. Okay, so next is the tertiary acid. So tertiary acids are compounds made up of hydrogen, oxygen, and a non-metal. So example, HClO2, it is chlorous acid. HClO3 is chloric acid. H2SO3 is sulfurous acid. And H2SO4 is sulfuric acid. So if you have the same non-metal but you only have different number of oxygen attached to it. So again, as what I have said a while ago, you have to familiarize the anions and its oxidation state. So here, makita ninyo na ang chlorine, na siya'y upat ka buok libangad, different number of atoms ay of oxygen ang na-attach sa iya ha. So diri sa example, kung naa siya'y 4, ang tawag sa iya is perchlorate. Dayon kung naa siya'y 3, ang tawag sa iya ha chlorate. So sa makita pod ninyo, ang compound nga nag-end og ATE or 8 is changed to IC. And while compounds nga nag-end og ITE or chloride and hypochlorite, gi-change siya to OUS. So you have to remember also that. So same with the this example, the sulfurous acid and the sulfuric acid. So the SO3 has SO3 is sulfite while SO4 is sulfate. So kung sulfate, kung ATE ang last, imuhang i-change into IC, sulfuric acid. While kung sulfite yung last, ITE, you change it to OUS, sulfurous acid. Okay? So next is base. These are the substances that yield hydroxide ions when dissolved in water. So the cation is named first, followed by the word hydroxide. So for example, NaOH, KOH, and BaOH2, You name first the cation, which is example for the NaOH, the sodium, and then you add the word hydroxide for the OH. And next is for the salts. These are compounds that is made up of cations other than hydrogen, an oxygen, and a non-metal as the central atom. So cation is named first, followed by the non-metal, whose ending is changed to the suffix ate or ide. So for example, the magnesium sulfite and the magnesium sulfate. So diba, nakita ninyo ninyo siya sa table. So you have to familiarize. Again, you have to familiarize the table of the common anions and cations. Okay. So for the activity 2, the common laboratory apparatus and operations, you also have to familiarize the uses of the glasswares or the apparatus. Also, you have to know how to transfer solids, powder solids or powder chemicals. You also have to um, know how to transfer liquids and to know how to heat using the test tube. So activity 3 is scientific measurements. So you have to familiarize again or memorize the SI units and the SI prefixes. Also, you have to memorize or familiarize the formula to get how to get the temperature and then the formula for density. Okay, so uncertainty in measurement. Accuracy denotes the nearness of measurement to its accepted value. So it refers to the correctness of the measured data. So accuracy is expressed in terms of error. So such errors may be absolute or relative. So for absolute error, ang imuhang formula is this. Again, when you are asked by the absolute error, ang imuhang answer has no sign. So dapat absolute siya. So wala siya sign. Always positive or wala din siya sign. So for example, imuhang observed value is 16 while imuhang accepted value is 15, imong answer dapat is negative 1. But you reported it as 1. So in quantitative laboratory experiments, absolute errors are referred to as experiment errors. So a relative error is generally more useful, and this is commonly expressed as percentage with the accepted value as the basis for comparison. So for the relative error, this is the formula. Precision. Precision is the agreement between numerical values of two or more measurements that have been made in the same way. So the simplest measure of precision is the average deviation. So the smaller division value, it is more precise. So example, so mo ni imo ang data nga nakuha for 3 trials. So you get the mean. Then, to get the division, you have to minus the mean from your data. But you dapat ka nang dili mo negative. Okay? So, then you get the mean for your division. So, kung gamay imuhang, kung nakay other nga data, kung i-compare ni mo siya sa lahi nga data, kung mas gamay ni imuhang division ani nga data, mas precise ka. Pero kung mas dako imuhang value sa division diri compare sa imong lahi nga data, so mas less precise ka. So the uncertainty in the measurement data is plus minus 0.03 grams. And the mass of the sample is expressed as 3.90 plus minus 0.03 grams. So precise measurements, however, are not necessarily accurate. So example, so naa si student A mo aniyang nakuha nga data for 4 trials and si student B for 4 trials. So iyahang mean is 28.246. Iya sa kang student B is 28. Okay? So ang division nga imong makuha is 0.001 for student A and for student B, 0.1. So, kinsa man ang mas precise sa ilaha. So again, the least value of the division value is the most precise. So student A's results having a smaller deviation are more precise than of student B. But, so, mao ni ang accepted value. So, you are asked kung kinsa man ang mas accurate sa ilaha or kinsay mas duol sa ilaha of data sa accepted value. So you get the absolute error. So the absolute error of student A is 0.192 while student B is 0.1. So student B results are more accurate because the error is smaller. So compare kang student A, mas gamay ang error ni absolute error ni student B. So mas precise si student B, bahalag dili siya precise. Okay? So rounding off numbers and significant figures. So first rule is that all non-zero digits are significant. So tanan dili zero nga digit are significant. So example, 19.73, that is all non-zero, so it has four significant figures or significant number. So number two, in case of zero, if zero appears between non-zero digits, they are considered significant. So for example, 104, naa siya sa between sa non-zero. Ang zero is naa siya sa tunga sa non-zero nga mga digit. So it is significant. So this 104 has three significant digits. Same with 10.04, di ba? Ang zero naa siya sa between, nasa tunga sa non-zero digits, so it is considered as significant. So 10.04 has four significant digits. Next is, if the zero appears to the right of the decimal in a number greater than 1, it is considered significant. Also, if the zero appears to the right of a significant digit in a number less than 1, it is considered significant. So, example, so ingon siya, kung ang zero daw is naa siya sa to the right sa decimal, nga ang naa sa left sa decimal is non-zero digit, so it is, the zero is significant. So for 56.00, naa siya 4 significant digit. Okay? So, ingon pod sa rule that ang zero nga naa siya sa left side, nag-una ang non-zero digit sa iyaha, so it is also significant. So for example, this 0.12, 1,200. So kaning zero diri is significant, but ang zero nga na diri sa atubangan is not significant. That is why ang 0.1200 has only 4 significant digits. Next, so for example, so same with the kuan rule number 2A. So kung naa siya sa between sa mga non-zero digits, it is considered as significant. Next is, if a zero appears in a number just to fix the position of the decimal point in a number less than 1, it is not significant since no measurement has been made. So example, bahalag naa siya sa left side or right side sa imong decimal pero kay wala siya non-zero digit diri before sa iyaha, it is not significant. Ang zero is not significant. So that is why for 0.005, imuha lang significant number is only 1. Same with the next example. So kung ang zero is wala siya walay before sa iyaha nga non-zero, dili siya considered as significant. So for this example, naa lang kay tulo ka significant numbers. Next, terminal zeros or zeros at the end of a number with no decimal point shown in a number are usually not significant. So example, 75,000, walay decimal diri. So ang significant lang niya is duha. Example, also another example, 100,000, walay decimal point diri. So iyang significant number is only 1. So, in mathematical operations, for the significant figures, the following rules apply. So, first is for addition and subtraction. So, ang definition is that the answer follows the smallest number of decimal places of numbers being added or subtracted. So, example, the first value has 2 decimal places while the second value has 5 decimal places. So, ingon sa rule nga pag mag-add ka or mag-minus ka, ang imuhang i-follow is ang smallest number of decimal places. Mao nang imong answer, imong pag-report sa imong answer na alang dapat duha ka decimal and not this one. Next example. So, bahalag na siya duha ka significant figures pero iyang decimal point is only 1, you should report your answer nga naa siya isa ka decimal place bahalag 2, 4, 5 iyang significant figures. Kay imuhang operation naman ni gamit is addition. So another example, so a problem. What is the volume of the irregular solid if the initial volume of water is 45.5 ml and the final volume is 66.45 ml? So in getting the volume for the irregular solid, you use a graduated cylinder. For example, you are getting the volume of a rock, bato. So, first nimo nga buhaton, magbutang ka og tubig sa graduated cylinder, and then that you measure the water. So, that is your initial volume sa imuhang water. So, para makuha nimo ang volume sa imuhang bato, imong ibutang sulod ang bato ay ang imong ibutang ang bato sa sulod sa graduated cylinder nga naay tubig. So of course, ma-change pud ang volume sa water. So that is your final volume. So para makuha nimo ang volume sa imuha nga irregular solid or sa imong bato, you minus the final volume to the initial volume para makita nimo unsa ang pila ang volume sa imong bato. So to get it, 66.45 ml minus 45.5 ml will give you 21.0. So you report it as only one decimal in 1 decimal places and not 20.95. So dire nag-round off na ka because one decimal naman imong need based sa rules sa significant figures para kung magamit kag addition or subtraction, diba? 1 decimal. Pero kay 9 naman ni siya. 9 naman imuhang last nga decimal. Ay, tapos 5 iyahang ganak sa iya. So mag-round off ka, di ba? Ang rules sa rounding off, rounding up, kung 5 or more than 5, dapat mag-round up na ka. So you round it as 21 and your report is at 21.0. Next is the multiplication and the division operation. So, ang imuhang answer ani dapat follows the least number of significant figures. Again, for the addition and subtraction, the least number of decimal places. But in multiplication and division, the least number of significant figures. So, example, the first value has 3 significant figures, while the second value has 2 significant figures. So that is why you report your answer na dapat duha ra ang significant figure. So example kani, so this is correct. The report is it as 9,800. So kung i-multiply ninyo mo, imong makuha nga answer is this, 9,776. Pero ingon sa rule nga dapat pag-report nimo sa imong answer ang least number of significant figures imong basihan. That is only 2 significant. So how will you report this 9,776 para duha ra yung significant figure? So imo siyang i-round off. Mo nang nahimo siya og 98,000 or you use the scientific notation which is 9.8 times 10 to the 3. Another example, you only have 5, first value it has a 1 significant figure, while the second value, you have 6 significant figures. So the answer should be 26,728.35. Pero ingon sa rule, ang imong pag-report kung mag-multiply ka is based sa imuhang least number of significant figures. So, pila ang least significant figure? So, only one. So, unsaon man nimo pag-report para mahimo ra siya one significant figure. So, you round off. That is why you report it as 30,000 or using the scientific notation as 3 times 10 to the 4. Okay. Example, a problem. So, calculate the density of mercury if 1.0 times 10 to the 2 grams occupies a volume of 7.36 centimeter cube. So, you know the formula of density. It is mass over volume. So, density is equal to the mass, which is in grams, and it has only two significant figures. So, scientific notation ni had to the power of 2 ni siya. So 1.0 has only two significant figure, while your volume has three significant figure. So your answer should be only have two significant figures. So the when you divide this, you have this answer 13.59. Pero ingon sa rule, dapat mag-base ka sa least number of significant figures, and that is only two. So you report it as 14 gram per centimeter cube. Okay, precision of an instrument. So the precision of an instrument signifies the smallest quantity that the instrument could be sensitive to or detect. So the formula for the precision on how you get the precision of your instrument is that P is equal to plus minus SC, which is the smallest calibration, divided by 2. So P is the precision, SC is the smallest calibration. So the question is, how will you get the smallest calibration? So the formula for smallest calibration is equal to the difference between any two scales divided by the number of divisions. So now the question is, how will you know unsa maning si two scales, unsa pud ni ang number of divisions? So example, na kay ruler, inani imong ruler. So how will you get the precision of this ruler? So ang formula is this, but you have to get first the smallest calibration. And the formula for the smallest calibration is this. So, ang meaning there is a difference between any two scales. So, magpili lang ka any. So, for example, 1 ug 2. So, kung dili ni siya si 1 ug si 2, si 4 ug si 5 na siya, pwede gyapon na nimo pilion. So, the difference. So, i-minus nimo. So, kani atong example, i-minus nimo si 2 kang 1. Kay mao atong gipili na scale. Then, ang next is the number of division. So, pila ang division between them? Mao na ang pasabot sa number of division. So, pila man ang division between them? You count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, mao na ang smallest number of division. So, you have to take note, you have to include this sa imong pag-count sa imong number of division. So, 2 minus 1 divided by 10 is 0.1. So, that is the smallest calibration. To get your precision, your 0.1 smallest calibration should be divided into 2 to give the plus minus 0.05. So, that is the precision of your instrument. Okay, so you have to take note that the number of decimal point in each reading should be the same as that of the precision of the instrument. So example sa letter A, imuhang kwaon or imong i-read unsa man ni nga measurement si A. So kabalo ka kung 1 ni siya, then 10 iyahang divisions dire, so 0.9 ni, 0.8, 0.7 ni siya. So dili lang nimo siya report as 0.7, but imong i-report is 0.70. Why? Again, because the number of decimal point in each reading should be the same as that of the precision of the instrument. So, kung pila imuhang decimal number sa imong precision sa imuhang instrument, maupod imuhang pag-report sa imong reading sa imong measurement. So dili lang dapat 0.7 imong ibutang, but 0.70 and then your precision, which is plus minus 0.05. Same with the letter B. Okay, so another example, the precision of the graduated cylinder. So again, the formula for the precision is equal to the smallest plus minus the smallest calibration divided by 2. So to get your smallest calibration, you have to get the any two scales. So magpili kag any two scales. So pili tag 5 o 4. So ano, wala man si 4 dira, ma'am. So, always remember nga, kanang, before ka makaabot og 5, kinahanglan na si 1 ml, 2 ml, 3 ml, o si 4 ml. Aya ka makaabot kang 5 ml. So, bahalag wala ni nabutang dira sila si 1, 2, 3, 4. Kabalo ka nga, kanipong mga tag-as diri, that is 1 ml, diba? 2, 3, and 4, ay din abot si 5. So, kung pilihon nimo si 5 o si 4, the next is, pila man ilahang number of divisions. So, pila ang divisions between them? That is 1, 2. So, divided by 2, you'll get 0.5. So, that is the smallest calibration. So, the precision of this graduated cylinder is, you divide your smallest calibration by 2, and you'll get 0.25. So how will you report your measurement or your reading in this graduated cylinder? For example, pila man ang reading ani nga water. So that is 3 point, 1, 2, 2.5. So not only 2.5, but you put 0, 2.5, 2.50 plus minus 0.25. That is 2.50 plus 0.25. Okay? Now, for the reading of your liquid, especially segregated cylinder, you have to read it equal sa imuhang eyesight. Dili sa taas, lugar mas taas ka sa imong graduated cylinder, dili pud nga mubo ra kay ka sa imuhang graduated cylinder, but equal sa imong eyesight ang dapat ang graduated cylinder. Okay, kung naa ka sa taas o naapod ka sa ubos sa imong graduated cylinder, na ay error sa imong pag-read sa imong volume. So another example, how will you get, what is the precision of this balance? So again, to get the smallest calibration, the difference of any two scales. So makita ninyo diri. So 6 of C, 5. Okay, so pila man ang number of divisions between them? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 iyang number of divisions. So that is 0.1 imong smallest calibration. So ang precision is plus minus 0.05. So imuhang reading for this balance is 245.60 plus minus 0.05. Kaya again, ang imuhang pag-report sa imuhang reading or sa imong answer is dapat same sa decimal point sa imuhang precision sa imong instrument. Another example, 50 ml graduated cylinder. So ang precision sa imuhang 50 ml graduated cylinder, so example, so, dili necessary nga ang next niya nga scale. So, 50 minus 40. So, pwede po 50 minus 30. So, example, 50 minus 30 atong gamiton. So, you have to count also the number of divisions between 30 to 50. And that is 20 divisions. So, your answer is 1. And for the precision, you divide it by 2. So, the answer is plus minus 0.5. 5, diba? Ang ano, 0.5, dili man 0.50. Pila man ang imuhang significant figure diri, diba? Isa lang. So, when you use the operation for division, ang imong answer dapat has the least number of significant figures. So, only 1. That is why you reflect your precision as 0.5. So, the reading for this is dili 50.00, but mag-base ka sa imong precision sa imong instrument, and that is 50.0 plus minus 0.5 ml. Next example, for the 100 ml graduated cylinder, pila man iyaha nga precision. Okay? So, atong gipili si 50 ug si 40, tapos yung number of division is 1, 2, 3, 1, 1, 2, 3, 4, 5. So 10 divided by 5, that is 2. And your precision is plus minus 1. So how will you report your answer for this reading? So that is 40 plus minus 1 ml. So wala siya decimal point kay imuhang precision has no decimal point. So that is the precision of an instrument. So dimensional analysis. So this makes use of conversion factors which could bridge the given information to the answer one is looking for. Organize the given data, which should include its units with the units of the unknown. So, ang dimension analysis, gabi ni siya ka-useful or gabi gid ni paggamit sa chemistry. That is why you practice how to use dimensional analysis. So, example, if a woman has a mass of 115 pounds, what is her mass in grams? So the calculation or the solution is this. You know that 1 pound is equal to 453.6 grams. So for your calculation, you first put the given unit. So ibutang nimo unsay given, tapos ang imong conversion factors. So kabalo ka nga ang isa ka pound naa siya worth siya sa 453.6 grams. So that is why ang pound or ang 115 pound nga woman naa siya 5 is equal to 5.22 times 10 to the 4 grams. Next, for another example, a cabinet has length of 8.00 meter. What is its length in inches? Again, you put your given unit, that is 8.00 meters. So, ang gipangita, pila man kang ka-inches. So, you know, based sa imuhang conversion factors, ang isa ka meter or ang 10 negative 2, pila man ang 10 to the negative 2, that is 0.001. Ba? 0.001 meter is equal to 1 centimeter. Pwede po na siya. Kung dili ka gusto og 0.00, butang nimo 100 centimeter is equal to 1 meter. Ba? Okay? So, 100 centimeter divided by 1 meter, tapos pila man ang conversion factor sa inches o sa centimeter. Kay imong desired man is inches. So you know that 1 inch is 2.54 centimeters. So you have to cancel, then you have your inches. Next, calculate the number of moles of glucose in 5.380 grams of glucose. Kani. So, ang given is 5.380. Ang gipangita, pila daw ka moles sa glucose kung naa kay 5.380 grams sa imong glucose. So, again, you put your given unit, then kabalo ka nga ang molecular weight sa glucose is 180.0 grams. Okay? So, ang iyang molecular weight, di ba, ang unit sa molecular weight is gram per mole. So, ang molecular weight sa glucose is 180.0 gram per mole. So, that is why ang iyahang conversion factor, kung naa kay 180 grams, mo pud na iyahang, ay mo na ang per mole niya. So, you cancel the units, and then you will have your mole glucose. So another example, calculate the mass of CO2 produced when 1 gram of C4H10 is burned. So given sa ani nga formula or equation, given ani nga equation, you can get the mass. So meaning mass, grams na, grams sa imuhang CO2 given ani nga equation. So ang given ra nga unit is 1 grams pero sa C4H10. So unsaon man nimo pag-calculate para makuha nimo ang gas sa imong CO2, mass sa imuhang CO2. So again, the given unit is C4H10 and then the molecular weight sa imuhang C4H10, that is gram per mole. Okay, so 58.0 gram of C4H10 per 1 mole of C4H10. Okay, so based sa equation, balance equation, you will also know the equivalent, kung pila ang equivalent sa isa ka mole sa C4H10 sa imuha nga CO2. So based sa aning nga equation, naa kay dapat duha ka mole sa imong C4H10 para makahimo ka og 8 nga carbon dioxide. So you also put this as your conversion factor, and then kay grams man or mass man ang ipangita sa CO2, so you also have to use the molecular weight of your carbon dioxide para imuhang end nga unit is gram. So cancel, 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 and you will have this for your mass of your CO2. Okay, so that's it for the until from lab safety to activity 3, the scientific measurement.